Well, Mark Oppett sent me the brand new dial scale for this radio, and as you can see, the difference in color is like night and day, literally. And he does it. Look at that, perfect job. It's a perfect job. Anyway, I've kind of been shortchanging that feller. I need to make 3 changes. I struck out on the poor guy. His name is not Mark Opat, it's Mark Oppett. And it's not spelled O-P-P-A-T-T, it's spelled O-P-P-A-T. Just one T. And the name of his website is not oldradioparts.com, it's oldradioparts.net. So, oldradioparts.net. So, Mark, sorry about that if you're watching this. I really had 3 strikes on that. He sent me the new dial scale. He made his run, and then I asked him if he could send me a piece of scrap dial scale material that I could put over my shadow meter, which he graciously did. So I'll be cutting this down, and we'll get rid of that old dark piece over the shadow meter, and we'll be able to see it even better. And we have one other problem that I have to resolve. This tube socket that holds my 80 rectifier tube is really loose and floppy. I've tried everything to tighten it up. It's just not going to work. So I went to Radio Days and I told them what my problem was, and I said, you know, I don't see a bottom mounted tube socket that you offer for these 80 rectifiers. And so Brian Sargent, who I don't know if he's an employee there or he's a part owner or owner, I'm not certain. I just know that he wrote me back. Now, he could have just as easily said, well, you know, sorry, we don't have what you need. But he didn't. He wrote back and he said, you know, I will go to the warehouse. And I believe I have a chassis down there that I can take a tube socket out of that'll work in your radio. And he did. And here it is right here. He sent it to me. And that's why I deal with Radio Days. They could have just as easily said, forget it, you know, we just don't have it, too bad. But they didn't do it. And he also sent me a tube shield. And it's not too rusty, not too bad, but in order to have my buddy chrome this thing like I did the others, all of that old nickel plating or cadmium or chrome or whatever it is that's on there has to come off. And I told you once before I used a Burns-O-Matic torch to do it. Just a standard old Burns-O-Matic torch. All I'm doing is just burning it right off, just like you would anything else. It's very thin, and you got to get it off there though in order to do a re-chrome job. This is how it's done. Alright, it's been totally burned, but you know, sometimes after it cools down, I wire brush it. It needs a second going over. But at least you know how to get that stuff off. You know, just be careful. You don't want to be burning yourself in the process. Slow and easy does it. One other thing I decided to do was there was a couple of knobs in this radio that were a different shade of brown. It looks to me like they had been replaced from another radio. Matter of fact, one of them was black. So I went ahead and I took some extra dark walnut toner. I cleaned them up with soap and water and a toothbrush, got all the crud out of all the little grooves and everything around the knobs, and then took some extra dark walnut toner lacquer, and I sprayed each one. And after they dried, I let them dry overnight. Then I came out and sprayed them with some clear enamel. Now remember, you can put enamel over lacquer, but not lacquer over enamel. If you put lacquer over enamel, it crinkles it up. And here is the new dial scale and the new piece of dial scale material on the shadow meter. You can really see the numbers now, nice and clear. Watch that shadow meter. You don't even have to guess if the shadow meter is moving anymore. You can see every movement. Looks great. And I know at least one of you is wondering how I attached this little piece to the front of the shadow meter. Later on it may have to come off. I don't know. It looks to me like the screen on the back of the dial glass is missing, so that's why I put it there. But I cut it down to where it cleared the tabs top and bottom, and then I just put a little dab of super glue here and a little dab of super glue here. and then pressed it in place. It's nice and solid. It's not going to go anywhere, but if I have to get it off, it'll come right off. Well, the new tube socket has been put in, and as usual, it's about, I guess it's around 10:30 at night. I am going to listen to a little WSM. So let's turn out the old light, and once again, put you through the paces here on WSM. At least this time we can actually see the numbers. Look how bright that thing is with that. I just can't get over what a little bit of work on a radio will actually produce, you know. If you take your time, and this whole project was just to show the new folks, take your time. There's no rush to any of this stuff. And, you know, you're not going to get a perfect radio when you're done, but you're going to get one that looks a whole lot better, performs a whole lot better, and hopefully lasts a whole lot better. Well, it's the next day, and boy, it's a nice, bright, sunny, almost like spring out here. The birds are flying around and chirping. I can't believe it's almost the first of the year. Oh, this is amazing. Just a warm day. I'm just going to sit out here in the deck and start this next part. Okay, what we're going to do when we align the radio, I want to go over some basics. We're going to adjust this capacitor, or these are actually trimmer caps. We're going to adjust 1, 2, 3 on the RF coil. We're going to adjust 1, 2, 3 on the oscillator set of coils, and we're going to adjust 1, 2, 3 on the antenna coils. We're also going to adjust the primary trimmer cap and the secondary trimmer cap, or the primary cap adjustment and on the primary and secondary of the first IF. And we're also going to do the primary and secondary adjustments on the second IF coils, right here, these two. The alignment of this radio calls for the adjustment of what's called a wave trap. Now, not all radios have wave traps, but this one does. It's a coil of wire. In this particular design, it's a 15 ohm coil of wire in series with a adjustable mica capacitor. The adjustment rod is right here for the cap. Here's that wave trap on the schematic. It's the coil and the adjustable mica capacitor. The purpose of that coil and capacitor in series to ground is to take a given frequency and get rid of it. And you can set that frequency by adjusting that capacitor. These two form what's called a resonant circuit. If I'm unable to adjust this thing during part of the alignment procedure, and it's not adjustable, but it is allowing frequencies to go through, it may be letting frequencies through that I don't want to have let through. I may want those frequencies to go into the radio. So if it's messing up, I can't adjust it. I may have to wind up disconnecting it right there, which won't make any difference. All of the signals then will go straight into the radio. Hopefully it'll adjust out without any problem. One of the pieces of equipment, I've already told you about signal generators in another video I put up, and frequency counters. This is another piece of test equipment I'll be using. It's called a vacuum tube voltmeter. It's the predecessor of the digital voltmeter. Now these things have special probes. You just can't hook any old probe up to it. This is a Heathkit model, and it has a little plug-in deal here. Of course, it would be Heathkit. Just about everything I own is Heathkit. Anyway, they have special little probes. You have two wires. You have ground, a little ground, and the probe itself has a switch on it. Some of the probes have a slide switch back and forth, little thumb switch up here. This one has kind of a hokey deal. I never did like the Heathkit switch. Their switch is on the bottom down here, and it flips around this way, all the way around, and to AC, and then it flips all the way around this way for taking DC readings. One way and then the other. Anyway, we're going to be turning this baby on to DC volts positive, and then we're going to select a scale, whichever one. We'll put my needle, about somewhere near the middle here, and then that's what we're going to hook up to the output, to the speaker. We're going to hook this, the probe in the ground. We're going to hook to the primary of the audio output transformer, and then the rest will be hooked into the front. So basically what we're doing is we will send a signal in here and then follow it all the way through by making our different adjustments and watch it come out here on this meter scale. Piece of cake. And we are about ready to go. I've decided to use my brand new old triplet signal generator to align this radio. It's been sitting around for who knows how many years. It's time it got a little exercise. And then of course I've got my frequency counter here, and I have the two connected together right now. The lead coming out from the frequency counter with a set of alligator clips connected to another set of alligator clips that lead back over to the signal generator. So when I set my frequency, I'll be able to first verify it on the frequency counter, and then I'll disconnect these wires and go ahead and hook the signal generator up to the radio where it's supposed to be. I also have the vacuum tube voltmeter over here, and its leads, I have the probe connected to a red lead to one side of the primary on the audio output transformer, and I have the negative lead coming from the vacuum tube voltmeter connected to the other side of the audio output transformer primary. We're now set to go. All we have to do is turn on all this stuff, let it warm up for about 30 minutes or so everything stabilizes to include the radio, and then we'll go ahead and start turning screws, which will all happen next time.